the deep dive overview on the global AI hackathon.
Yeah,
All that.
we've been talking about the hackathon stuff a little bit this week, and there's I don't know if it's a consensus, but there's a discussion anyway that maybe that's our best positioning for the types of things that we're best suited to do. Where we've been struggling with some of our certification and what does a certification mean in a world where you can just ask ChatGPT to do your certification. So the hackathon is almost like proof of what you can do on a certain like problem. So maybe we, I'm not saying we don't do certifications, but maybe it's based in part by what have you built?
Yeah.
This
Yep.
is kind of the whole
Absolutely.
basis behind that theory I was telling you about, Ruben, is where you can't test for the answer anymore. You have to test for the process. And what the hackathon is doing is it's testing the process, which is the only way to actually test people's understanding and what their knowledge is anymore. You're absolutely right about that.
Mhm. You're a perfect example. You and Nick, in particular, you guys are creating these amazing things. You're testing, you're pushing the boundaries, and I can go to your repos and your NPMs and whatever and see all the things you're building and try them and use them. There's theoretical, and then there's like, hey, I built this crazy stuff and it works. Anyway, I lean towards built it, made it work. Speaking of, I keep seeing these mentionings of the tune system that for like optimizing like prompts and things. Anyway, built that, been there, done that, built that like a year ago. Um, all right, so we're at the top of the hour. Here we are, November 14th, not 7th. I don't know why Zoom's saying it's the 7th. And by the way, I've got a new camera coming later this afternoon, so I should be a better picture here, hopefully. And we've got some good stuff lined up today. So Rob, what do we got lined up here?
Yeah. Yeah. Great. We've got a couple guests from CIQ today. So Brian and Dan. Brian Dawson, he's currently the director of product management for Rocky Linux. And so they're going to be showing us some of the infrastructure work they're doing for the next generation of AI and ML. So they've been building kernel optimized Linux for AI. So it'll be very interesting to see what it is that's coming out of that. So we got those two fellows, and then Kunal's going to be sharing his experiences at the Educators Conference in Vermont. And then we're going to do the announce and the deep dive of the structure of the first global AI hackathon. This has emerged out of the Paris chapter, and our scenes with us to go through all the details and the specifics of what that looks like. And there's some pretty fascinating and exciting partners that are engaged in that. So it's going to be interesting. The whole year seems to be building towards a crescendo roof. Tokyo is about to launch December 3rd, and there's a lot of real interesting heavy hitters and scholars involved in the Tokyo chapter. And then this global hackathon that's coming out of France. It's going to be interesting and a great opportunity for members around the world to participate and to table teams from chapters and members all over the place. So really exciting stuff. So we'll dive into all that today.
Okay. Yeah. And by the way, for those who are interested, there's a group that have formed to do a series of Boston meetups. And I think it's going to happen at the Microsoft offices in Boston, hopefully in a few weeks. So if anyone's in Boston or wants to get involved, Vlad and the crew are putting that together. Happy to help as well. And Intralytics is offered to help sponsor some of the, I guess, the pizza. So thanks to the Intralytics crew, Eric and John and those guys.
Nice.
So that's exciting for Boston. It's a good spot for us.
Also, San
Um,
Diego. San Diego has emerged. There's been a couple members that want to get something together there. So anybody in and around San Diego, fire off some messages because there's a group forming there.
yeah. And we were briefly discussing this before the call in our pre-show, which I guess today is the actual show since I think it was streaming the whole time. But regardless, there's been a lot of talk in regards to sort of a hackathon approach that we could maybe take as part of what we do as an organization. And let's be honest, the Agentics Foundation is pretty ad hoc. Like we're like the
Hmm.
opposite of the Linux Foundation, right? We're a bunch of we're a ragtag team of folks that are just excited to get together and talk about, agentics and stuff that we're building, which kind of works for us, I guess. So that said, it probably makes sense for us to try to maybe do a more hackathon style to the things we're doing, where we can get together, build for purpose, that kind of thing. You know?
Yeah, yeah. I think it's a great fit, and this will be a really interesting run through exercise, bringing everybody, with participants all over the place. Really neat.
Yeah, for sure. And as well, so a few few updates before I jump in here. I see we got as you mentioned, we've got our one of our favorite long time callers here. Chris Royce has joined. Hey Chris, what are you up to? Hope he's still there. Put him on the spot. All
There
right,
he is. There he
maybe.
is.
Me,
No, he's here.
I
Yeah.
have been up to designing a new search algorithm that specially designed to provide the AIs with all the context that could possibly be used to answer a query from whatever data set you might have, whatever knowledge graph data set you might have. So that's what I've been
Nice.
working on, which I'm like
Yes.
a week off from that, but I think that's important, right? Is identifying if you have an answer or a query, what is all the knowledge in the world or all the knowledge in a curated data set that you have that could possibly be applied to coming up with an answer to whatever your question or query is. So whether that's whatever it might be, right now I'm just building it off of ConceptNet, which is just a data set of basically common sense, all the concepts in the English language, or at least like 1.8 million of them. But then this can also be used for, say, medical, right? You could load up like the UMLS, like medical ontology, like it's 105 ontologies that the National Institute of Health manages. And then say you put in like symptoms and you want to know like what's wrong with a patient. Well, what if you could see all of the reasoning paths in that data set that could lead in any way, shape, or form to say a cure or identifying the outcome of a patient's, whatever they're afflicted with. So
Mhm.
that's what I've been coming up with is
Nice.
a new
The
search algorithm.
We expect nothing less, Chris.
Yeah, you're definitely in the right track. I was approached by a cancer research organization, a university organization, and essentially what they ended up doing was pointing the agent DB system that I've devised that basically finds kind of reasoning and pattern recognition and learning within sort of in this case genomic data. And what they're telling me, and take this with a bit of a grain of salt, but what they ended up doing was pointing at their genomic database, and they let it run for I think they said 2 hours. And essentially, at the end of the 2 hours, according to the output anyway, again, take it with a grain of salt, they said they found 800 new novel connections for different types of cancers, like colorectal and a few others. And they said that, and this is a major organization. They said in a normal year, they do 20 novel discoveries. And these are fully researched, just in fairness. But in 2 hours, they were able to find at least the basis to potentially explore 800. Now, obviously, a lot more work needs to go into it to actually verify and validate and all that sort of stuff. But what that does show, to Chris's point, is the potential for this technology to find these sort of hidden patterns in this data that is very difficult for humans to find, and also noting, and I sound like a broken record when I say this, you don't need to brute force it. You don't need a GPU cluster. You don't need all these sort of fancy Python and PyTorch systems. What you need is fast, accurate, grounded, recursive systems that are capable of doing these things, essentially very, very quickly and finding those patterns rather than brute forcing it. And I'm not saying that GPUs aren't dead or anything. They obviously have their place, but for a lot of the things, you just need it to be fast. And a CPU is a decent CPU is more is in a decent vector system is all you need. So to that point, I think let's jump in quickly, and I'm going to give you an update. So last week we we discussed some of the security related work that I was doing, and what was interesting, and I'm going to give you an update because this week our friends at Anthropic came out with this Anthropic disrupting the first reported AI orchestrated cyber espionage campaign. So this is because this is directly related to the work that I did last week to show you the AI defense system that is intended to protect against this very type of exploitation. Now, what's interesting in here is they're calling it vibe hacking, which I think we've been describing for literally a year and a half at this point. But the idea that you can use these agents to quickly and adaptively find and exploit and cover your tracks in using, the things that we're almost taking for granted. Now, this seems like a little bit of hyperbole. Like they're saying in mid-September, we detected a highly sophisticated cyber espionage. This is not highly sophisticated. This is literally a Tuesday afternoon on our one of our live casts. Like it's using the Claude flows and the agent flows and the stuff that we're almost taking for granted on a daily basis to create these kind of recursive systems. But apparently, they think it's a highly sophisticated Chinese state-sponsored group. I think they just used Claude Code and did some agents, but okay, we'll go along with that for a moment. This activity escalated our previous vibe hacking findings. This whole paper, which if you can call it that, just kind of reads a little bit like a marketing tool for like using their system, but regardless, the simplified architecture of the operation. So they've got MCPs. They've got multiple agents, I guess is what these little icons represent. It's not really clear what that actually means. I'm assuming those are agents. We got web app, and then we have each agent devoted to a different topic. Again, a swarm. It's literally the architecture of a swarm here. And let's dig in a little deeper. They're saying the threat actor developed an autonomous hack framework use Cloud Code and standard. Did they, or did they just go and use this? Now, this is the problem we face. So they all the hyperbole aside, what this system does is essentially allows you to sort of look at your own environment, hopefully don't look at others, and then create a real-time sort of assessment of the information flowing to and from it, and doing that in really, really fast sort of succession, right? In this case, I'm actually be able to get better than this. This is an average. This isn't even the lowest latency. So 0.05 milliseconds. And what that does is sort of creates these loops that are capable of seeing the stream and saying, is this something that's potentially exploiting my system? Is this something that's potentially manipulating the way I think? We can do that with both imagery, audio, video. So as you are sort of interacting with the system, you can understand, well, this is an AI bot that I'm talking to, and it's trying to convince me to buy something, or trying to convince me to vote in a certain way, or trying to manipulate me in a certain way. So, for example, you could use this in the case of, let's say, someone who's has mental health challenges that are thinking certain things, or older generation that might be more susceptible to exploitation. This type of application could essentially figure out where and how they're being manipulated. Now, unlike what they've outlined in the previous their paper there, I've included neurosymbolics. So they're assuming that the exploit is happening with normal language. I'm assuming that the exploit isn't happening with normal language at all, and it could be happening with other secondary forms of exploitation that are using symbolic structures, mathematics being the most obvious. So now here's the problem, and I know, Rob, you're on Starlink. So to our friends at the NSA, this just as this just as easily could be used on the flip side of protection and exploit. Like that's the worrisome part. And I'm not saying that Chinese went and used this. I only put it out last week, and they said it was in September. So the key here is using understanding what's possible, and I think what this report does at least is validates that this kind of idea of autonomous driven with human supervision. I don't think the the human supervision is even necessary. Like other than set and forget, once you've got this thing running, there's no human involvement. There's no, this human operator maintains minimal direct engagement. It's true, an estimated 10 to 20% total human effort. Yeah, that's the 10 to 20% human effort is me getting up in the morning looking at if anyone's tried to hack me, or in the case of someone trying to exploit the system, seeing what fish I've caught overnight, right? And that's the danger of the system. So I think that they've done a good job of illustrating the problem. Now, I think the approach that we've taken in terms of the AI, the AI defense system is a good sort of counter to this. So the idea of not only is fighting the sort of exploits with smart, capable systems capable of adapting as quickly as the sort of adversary is trying to take advantage of you. And that's kind of what I'm trying to get at. And in a long, convoluted way, I'm saying use it for good, use it to protect yourself against supposed state actors, and I think that this is almost proof that we're on the right track of what we can do. So interesting timing. I think I share this in the I'll pop this in the text chat for you guys if you want to take a closer look. There you go. One other thing. I still got a few minutes here. I'm going quick today. I've come up with a new sort of novel. I don't know, novel. A new architecture for me anyway. And I'm next week. This is really beta, so if you go and try it, don't complain that it doesn't work just yet. But I'm giving you a little sneak peek of my NeuroTrader, and what I really want to show you, and this is probably I'll give you a full demo next week. But basically, this is the second generation of my NeuroTrader. This is using similar philosophy to the defense system I was showing you, but applied to like trading stocks and stuff. But what I really want to show you is something that I've come up with that works really well. I'm going through all the various things here. Okay. So what I've started to do is use this multi-package approach where I create a kind of Lego building block approach to the various components that I'm building in the system. And I showed some of this yesterday on the Vibecast. But essentially, what I'm doing is creating a combination of crates. So a lot of the logic, actually most of the logic that you're going to see here is actually not built in TypeScript at all. I'm using npm as a delivery mechanism, and then I'm packaging each of these as using something called the NAPI. And the NAPI, unlike the WASM that I've previously been using, so just to give you a quick, what the hell is he talking about? A WASM is a WebAssembly, and a WebAssembly allows me essentially to take a Rust or other languages, Go, I guess, and whatnot, and kind of package it in a way that can run sort of independently of any environment, right? It runs in the browser and or on your desktop or whatever, but it limits access to the system resources. So it's really good at sort of taking complex algos and packaging them up. But what it lacks is the ability to interact with the infrastructure itself, like your CPUs or your disk and stuff like that. It's possible, and there's hacks around it, and that's where I use kind of like the TypeScript scaffolding to sort of act as a bridge between the logic and the system, but that slows it down. So now what I'm doing is and I think, where can I find that? Where's my core here? I think it's yeah, I think I put it in this one here. So what I'm doing is I'm packaging something called a .node, and I think I put it in this one. Yeah, here it is. It's in bin, possibly? No, gotta go back. Lib. No, I'm in the wrong. I think I might be in the wrong one altogether. But basically, I think it's MCP. Sorry, this is a work in progress. My apologies, but I think I put it in the MCP one. I really do want to show you what it does, and that's in native. All right. So the native, this file you see here, so I can compile these highly sophisticated, powerful sort of Rust-based components that run in ridiculously low amounts of time. And then as you install these libraries, it basically automatically installs and compiles without you having to really know or understand what it's doing in the most simple terms. And this gives me the ability to sort of bypass the complexities of the stuff that I was doing in Rust directly, which if you go to create RuveNet and you see my most recent updates, you'll see that I've got these different parts that I've made. Now, if you want to use these, you essentially have to compile them. And that takes 20 minutes, half an hour potentially for each. So, and then you get to do each one, and it's a lot of work. So it takes all this kind of complexity and makes it basically just npx install. So long story short, going forward, for more complicated things, this is probably the architecture I'm going to be using. And then the drawback is I have to basically pre-compile each of these .node files for Windows or Linux or Mac OS. But I'm basically doing that so you don't have to. And so if you're looking to build really powerful, complex, highly scalable things, this is how you're probably going to want to start thinking about doing that. Um, and next week I'll actually jump in and show you exactly how this stuff is just incredible in terms of the results I've been getting, in terms of the ability to. And let me show you some of the stats here before I end here. So this is my benchmark. So I'm always benchmarking. My early stats are really good. So for example, speed wise, I compare it against Quant Connect and Backtrade and Zipline and a few others. I'm in most cases I'm 10 times faster than the state of the art. Random dude in Oakville, Ontario, that's competing with some of the largest and best sort of quants on the planet by literally just pointing my Claude swarm at it and saying, be better. And then I'm using CPUs to do all this. I'm 10 times faster than PyTorch on a CPU. Back to, do you really need to do that? And I'm actually, even on, when you even compare it on GPUs, I'm in this case 60 times faster. Which means I can spawn 1,000 agents that look at 1,000 different potential variables for like stocks and related sort of correlations all at once, and it costs me 12 cents. Like this was 1,000 trades for 12 cents. So I'm going to open source the whole damn thing because why not? And it's sort of kind of open source. For those who want to try it, I'm still baking it. So don't bug me if there's bugs. I'm going to clean it up this weekend and prepare it for you guys next week. But this will be the big my big release next week. Yeah, that's where I'm heading right now. Again, look, a lot of the breakthroughs that I've been doing this week are almost entirely based on my agent DB, and that that's been my sort of focus over the. Oops, I agent DB. Yeah, so almost everything I'm doing is some variant on this kind of concepts of reasoning, learning, and kind of high performance vector. This has been my breakthrough, and I think that if of all the things that I've built this year, maybe other than the Claude Flow system, which has been the sort of, I don't know, spark, if pun intended, of my ability to build, this really takes me down the path of being able to create these highly efficient self-learning systems that don't require expensive GPU infrastructure to support. And what's last comment. I know I'm running a little long here, but last comment is when I'm building this stuff, I essentially ask the system, what does the future look like 20 years from now? Go build me that. That's literally how I come up with this stuff. So it's I know Nick is a particular fan of this idea of manifestation. This literally manifests the future. Like, what does the future look like? Okay, how do I build that future? Let's go build it. And then it like creates the thing that doesn't exist that should exist in the future. This is like, and then all these parts that I'm showing you fit together like these little blocks that are interconnected to this imaginary future that the AI is telling me should exist. Interestingly, now it does exist. So there we go. Interesting times. Um, yeah, the power of manifest. Yeah, Nick's the one that turned me on to this manifestation stuff. Nick, you've been working on some manifestation apps, haven't you, or some sort of app that sort of productizes this or something like
Yeah,
that?
I call it quantumvibe.ai. Yeah, it's still pretty half baked, but there's a lot of stuff in there that anyone that wants to use it, just let me know. I'll hook you up with an account.
And you've been building some crazy stuff too recently, right? Like I saw you took that idea to do like a land graph and a few other things.
Yeah, I did use your Spark spec for LangGraph, and then I just used Claude Web and I just let it run. Just sort of like ran while I was asleep, and then I woke up and it was pretty much done.
Oh, and
Yeah.
by the way, for those who are interested in seeing like crazy cutting edge whatever, I have a vibe cast. So a lot of the stuff I've been doing, similar to what Nick described here, I've been building using. Oh, did I do the right screen? Yeah, I think I did. All right. Yeah. If you go to the Vibecast repo and you go to branches, this is when I go into like Claude Code or whatever, and I'm doing my just fooling around on my phone, watching, Welcome to Derry or whatever. I should be paying attention. My son's in the show, but you get the idea. Sit in front of the TV for a few minutes. I'm popping these in, and I'm choosing my Vibecast repo as kind of the place I mess around. You can see if you want to explore, you can find like different things. Like here's one I did this morning just on my exercise bike. This is a change management expert system. The crazy thing is this stuff all works. I do think the Claude Code web is amazing. It's a little buggy, and there's a tendency for it to continue to run forever. I don't know what that's all about, but yeah, it's really good at this sort of thing. So let's see what else we got here. I've got the Claude input. Here's another example yesterday. So what's this one? This is Martin's. This is Martin's robot operating system 3. Like it built all this stuff, and it seems to work. So, and this is entirely built on basic Claude Web. Yeah, you can see here. Here's the examples of how things can work, different robots, and here are the crates. So I haven't published this yet because there's just too much stuff to look at. But you can see all of it, how it's built. Like there's this is probably 100,000 lines of code in here. But this uses exactly the same approach. I pointed at my gist and said, go build me that. So if you go to gist, you can see sort of the life cycle here quickly. Yeah, here you go. Medical research swarm, meta discovery on research integrity. It's a random idea. Oh, by the way, I've updated all my MCPs as well to the latest protocol. If you want to update your MCPs to the latest protocol, point at this, go in here, say, build me a MCP using blah, bang. And that's all you need to do. And you can see my specs. So this would be the spec for the latest MCP protocol, or here's the spec for the robot system Martin and I were working on. This is this is probably 100 pages of stuff. But this will give you an idea of how I'm building at the moment. All
Ruth,
right. Yeah.
Ruth, how you got the specification? Because it was supposed to be released on the 14th and the 25th, no? So it's
I went
under
on to the
development.
I went on to the discussion group, and there was a request for feedback. I took the proposed specification, and I implemented it. I implemented the latest MCP specification on Claude Flow, and I did that on Tuesday. So I like being first. I don't know.
It's
I've
just a
got
thing.
so many. Yeah. By the way, okay. Here's the part that's important if you want to understand the latest specification. There's some cool stuff around sandbox and authentication, but the real part that's really interesting about the latest MCP specification is actually the way that they're using the JSON files. And I've implemented that as an option in Claude Flow. I might switch to the full implementation next week when they go live in case there's any last second changes. But if you look at my implementation of the neuro trading system, you'll see it let me see if I can find that for you guys quick, just because I think it's interesting.
Do you already implement it to the trading system?
Yeah, I did. I'm using it on that. So now we go to the MCP implementation here. I gotta find it here, somewhere down here. All right, MCP, I think it's the protocol, possibly. I should probably combine those, but anyway. No, I chose the wrong one. So I'm gonna this is still pretty alpha. But what I want to show you is the structure. So it went from a kind of load all the MCP tools at once to I gotta find where I'm at here. Where is it? Oh, I'm on the wrong page. To this idea of, here we go, code. Where the heck would it be? Tools, I think. Yeah, here it is. Okay. So the new version of MCP, it allows you to basically make it doesn't load all the tools until you want to make the request for the tools. So what they've done is they've offloaded that. So rather than having, in my case, 100,000 tokens, which was crazy, MCPs, now I'm down to 2,000 tokens, which basically describes each of these tools. And then if you want to use the adaptive strategy or whatever, then it describes it in JSON like this. And that approach essentially lowers the overall token consumption dramatically. You can see each of these files is 1K or whatever, and that adds up quite quickly, right? Because in the case of this trading system, there's 100 different endpoints for syndication or getting prediction or getting portfolio status. Now that's all offloaded to these JSON files. So all you need to do is basically point it at that gist I was showing you earlier, and it'll just work. That's literally how I built this this particular part of it, which is light and fast. The other thing that's cool is the sandboxing. The sandbox capability is particularly well suited for the agentic flow system that I devised, which is a sandbox tool, essentially. So I've already sandboxed it. So I just, next week, I'm probably going to modify that to use the new sandboxing specification for MCP. So you can basically spawn up these secondary agents. They don't call them agents, they call them sandboxes, but they're essentially agents. So it's pretty cool that now we can do the agent stuff directly in MCP, which means those specs that like Google and others came out with, A2A and ACP and whatever, those are totally useless at this point. They've basically taken all the best parts of those specs and combined it with the MCP. So interesting note.
Just one more question that I have about that one. Actually, you have a post on LinkedIn about it. This Tom momentum that trying to replace JSONs, and it's getting some momentum on the social media. And you mentioned that you already built something similar last year, but you think it will be interesting in this matter to try to reduce the token usage?
Yeah, what was it? 10 months ago. So it wasn't quite. It was, I guess that was what, January or something. So what I did is I used neurosymbolic structures. So I encode the information directly in different types of logarithmic structures like Mandarin or Sanskrit or whatever. And depending on the level of like how much you want to condense it, you can get, in my case, I was able to get 98% condensing. And what the craziest part of this, it just kind of magically worked. So you can see here an example. I'm not sure if that's zoomed in enough. But basically, you can take a paragraph of text and it changes it into this. And so this is 35 tokens. This was 85 tokens. And that was like not me cranking it up all the way. Yeah, so I think I disabled my my synthlang site, but I think I had synthlang.fly.dev or something. Yeah, this is the site, and you can. I don't have it currently active because I was trying to save a buck. But if you take that repo, you can literally run it. You can see the token usage. You can crank that up. You can see how much you save. They're saving 46%. I'm saving 95% with a 1900% speed increase. Or 1900% speed increase.
But this is something that happens before the LLM or an after, or is actually something that will be understood by the LLM?
What's weird, this is emergent property. LLM just magically understands it. And to prove it, here, all we need to do is we grab this, we jump into, let's say, ChatGPT.
Yeah.
And we paste this in. Right, it's a really abridged version. Now I get thinking going. We'll see. Well, I never tried thinking because thinking didn't exist when I built it. We'll see what happens. But basically, it just kind of magically works. Now I don't really know why or how it magically works, but it does. So anyway, I probably should have done the audio, but and it reconstructs it. Now I could have told it to reconstruct it in a normal paragraph. I just did it quick. But you can see it took this really small amount of text and it reconstructs it in a much more verbose output, and it seems to hold its context perfectly, which is crazy.
Yeah, it's crazy. It's interesting because they probably were never trained in this language or whatever.
Yeah. And you can.
Hey, Ruv, I just have a question for you, and I guess everybody else who can chime in. So I was looking at the whole prompts and token the whole like past week, basically, right? And I don't have hard numbers, but I got very strong suspicion that not all tokens are the same. So, like for example, like tokens like the and they kind of tend to just disappear, and they don't actually affect much performance if you put like 1,000, like ace or
You're
1,000,
talking
like the
blank space. So remember,
blank space actually affects blank space is a killer, like because I was looking at the markdown tables. If you actually just remove the spaces there and just keep the structure, like it improves performance like crazy. But some tokens like articles like A and there, like they just you can put like thousands of them or remove them. It increases the token count, but it doesn't affect the like round trip time or any like performance.
it increases the cost. And
It
that's the
increases
biggest.
the cost, right? But it seems like the model itself, like it doesn't work as hard. It works on harder on some tokens than the other. That's what's my suspicion is. Like, have you seen anything like that?
Yes, it does. So and you can prove that by doing a comparison in terms of time. So do normal English and then compare
Mm-hmm.
it to something that has more sort of dense information like Mandarin Chinese.
Mm-hmm.
And take the same paragraph in both. Mandarin Chinese would use probably half the amount of characters, but the density of information within that is much more because
Mm-hmm.
the characters encode more information structurally.
Right.
So, and you can see though that because even though it's less tokens, it has to think harder for the Mandarin.
Oh, it does? But okay, so Mandarin is actually interesting example because what LLMs see, they kind of speak Mandarin because if you have a water, for example, like English word water, right? That's one token. And the Chinese character for the water is probably also one. I don't think, but I suspect it's also one token, right? So that might be the same amount of information, like not in the characters, but in how much you.
I
My
think.
my
Oh, sorry, go ahead.
understanding of I'm not a Mandarin expert at all. I tried to learn it a little bit, but I don't know if anyone here speaks better Mandarin. But Mandarin, basically, from what I understand, there are only 400 characters with 6 to 7 tones, right? So based on the tone, the same character means different things. So effectively, it's a
That
sound.
only for spoken language. So for like on the print, the characters that are the graphical
There are 4
characters,
in
they don't
print.
have tone.
So
What?
in Mandarin, proper Mandarin, there is 4, but in actual Chinese, there are up to 6 or up to 12 or so. Quite a number more. Standardized, it's like 4.
Depends what Chinese you talk. I mean, I don't know the Chinese people here. I mean, I studied it.
I was using. I'm not an expert either, but I was using simplified
Yeah.
Chinese characters.
Okay. So simplified traditional does matter for tokens because that is just the way they drawn. Like so, it's for example, like the word for land, like in traditional, it's very like intricate kind of thing, and in simplified, it's like a 3 lines, but it means the same thing, and it's the same like they all map to the same Unicode like code, so it doesn't matter. Like yeah, but I think tones don't matter because tones are it's a spoken concept. Like so when you like when it's printed characters, they don't have tones.
Yeah. All right. I think we need to move on to
Okay.
our first presentation. Rob, who do we got lined up? I think we got Rocky Linux.
Yeah, that's right. We got Rocky Linux, and it's Brian and Dan. How are you, Dan? How are you, Brian?
Doing good. How are you, Rob?
Wonderful.
Great.
Welcome.
Great.
Thank you for having us on here. So a little bit about us, then we can kind of kick into the presentation. We're CIQ. We're the commercial backers of Rocky Linux. I'm sure that many of you are aware of the CentOS debacle that happened over the last couple of years. Our founder, Gregory Kurtzer, was actually one of the founding team of CentOS, and he created Rocky Linux to kind of alleviate that gap in the market, if you may. So what we're building now is the next generation of secure and performant Linux for AI, more specifically sovereign AI. Honestly, our genuine understanding is that we think that OS is an under-addressed surface area when it comes to performance and security, especially when there's massive investment going into AI, specifically with the associated hardware with it. So today I brought on our Director of Product Management, Brian Dawson, and he's just going to walk you through how we make it happen.
Awesome. Thanks, Dan. I'll go ahead and go back to sharing, get back into the slide deck. And, just as Dan set us up for today, I want to share with you our thesis and then also initial proof on that thesis that you can gain significant performance for your AI ML workloads with optimized Linux. And the start is that what we've seen is with our first iteration of Rocky Linux from CIQ, we have recognized very early a 90% improvement in setup time, which I'll go into detail on, and nearly a 10% improvement in inference throughput, tokens per second, over what is the dominant OS Ubuntu. And so, our statement and our recognition is if you're not considering the OS that is running your workloads, then time, money, and opportunity are being wasted. So to jump right into some of the benchmarks to set up discussion, sort of our narrow case benchmark, sort of extracting some of the ML perf or ML commons benchmarks and focusing on throughput. Throughput in particular in terms of text and image inference. We have found that of 6 of the tests we found, for 5 of the tests, our workload optimized distribution, Rocky Linux from CIQ for AI, outperformed both the community edition as well as Ubuntu 2.5 and Ubuntu 2.4, in some cases by nearly 10%. The other aspect where we feel that we can help solve emerging challenges with the OS is that critical surface between your models and your app layer and the hardware that it's running on is going to be in setup. So we did a series of runs of sort of scripted installs from a clean install of a base OS to your first token being output from the LLM. That included downloading the model, executing code to feed it a prompt, and having that prompt come out of the other side. So sort of a version of time to first token, but it's almost installation to first token, or what we've been calling time to inference. And what we found is that there's a 90% reduction. In this case, it's a 30-minute to 3-minute and 43-second improvement. And frankly, because this is a scripted install, removing human error, capturing a level of Linux expertise in the script, and also coming from a clean install, I'm pretty comfortable saying that this is an extremely happy path. So to talk for a minute about why we're doing this, right? We had an initial thesis in looking at the market that we were seeing rising costs as sort of AI adoption matured and more people were moving from experimentation and or training into production at scale, that at estimates the increase in cost is 3 to 4 times to run inference workloads as opposed to training workloads. The prediction is that in coming years, we may see 10x. We also know that performance is important, not only in terms of your infrastructure and GPU utilization, but also just the experience that you deliver your customers, clients, or end users. And while people have traditionally focused on security and stability for kind of the OSs that run their production workloads, we are in a place where we need security, stability, and performance. As Dan said, we also strongly believe and are seeing, and I'd love to hear thoughts when we get into discussion, that OSS models are catching up with the trillion weight models. We're moving beyond API-based consumption to self-hosted open source models and sovereign AI, and that increases the focus on deployment complexity, right? The need to be able to kind of have at least the lowest common denominator baseline that we can rapidly get deployed, know it's properly configured for our workloads, and absent configuration errors. And the other thing is, again, when we come back to enterprise Linux, I see we have a number of Linux system admins in here, right? RHEL and other enterprise Linux distributions have been chosen for security, compliance, stability, reliability, as opposed to being bleeding edge. So as we're, pursuing sovereign AI, managing sort of crown jewel IP and data, it becomes more and more important that we are retaining that security and compliance while we're pursuing speed and performance.
Nice, Brian. And closing thoughts?
Closing thoughts are look into RLCAI to see if it fits your needs and helps improve the performance in your workloads. And then Dan will land us with the
just really quickly. We're currently in tech preview with RLCAI. If you're interested, go to the CIQ website, sign up, and submit a form. We'd be happy to have any testers, community members, anybody involved have it in the tech preview. And I'm also building a startup program. So my goal is to get enterprise level HPC grade tooling into the hand of startups, specifically for AI workloads and training. So we're building a 6-12-6, 6 months free, 12 months highly discounted, like 80-90% off. And the latter of that is like 60-70% off as well. So we're trying to get this in the hands of small scale companies that want to have secure, performant OS. So thank you guys.
So
Really
great presentation, guys. I appreciate taking the time to show us. You called it an agentic, or is this AI? Because I don't see the agentic. I see some of the GPU stuff. So tell me, what you're doing for like agents and things like that.
So I think a key clarification there is we are not doing anything specifically for agents necessarily. What we are doing is tackling that surface area between the hardware and the loads that you were running on top of it. I think when we call out agentic AI, it is ultimately at the end of the day what would support other inference workloads, and that is increasing memory throughput, ensuring that the CPU and GPU communication can keep the GPU fed. Also ensuring that, as you talked about earlier, Ravon, when you are focused on CPU workloads, that we are configuring the kernel and configuring the user space to ensure that you are getting sort of maximum performance even for CPU only workloads.
And so you're basically kernel optimization. Is that predominantly what you guys are doing?
It's a what we are based. So first it's a pre-configured sort of and validated instance where by default we include the latest upstream kernel, which with itself comes with wider hardware support and hardware optimizations. We include the CUDA, the entire CUDA stack, as well as the ROC-M stack and ultimately the Intel Gaudi stack. And then what we do is we build PyTorch on top of that. So what we do is we strategically optimize every layer of that stack effectively, right? So there may be PyTorch build flags, there may be kernel build flags, there may be user space build flags, like rebuilding glibc.
So you're essentially optimizing Python.
No. We do
why
not rebuild Python, but I think you're saying
why do I need all that for an agent? Like all the things you just mentioned are all the stuff I strip out of an OS.
Well, what do you call? And I guess how do you access the CPU? So I saw you called out CPU workloads, right? You are still going through the OS and you're still going through the drivers, correct?
Yes. Yeah. So for low latency, I would use Firecracker. So that would sit on the sort of lowest level of virtualization. And generally speaking, I'm using some stripped down version of Ubuntu, as you're probably aware. So I'm getting rid of all the extraneous things that I don't want.
Services and
and I'm attempting to run it in as close to an immutable form as I can. Right.
Nice.
So.
Okay.
So there's obviously limits to immutability within an OS, but what I'm attempting to do is take a large monolithic OS and make it micro, right?
Right.
And
fair.
so, and the reason I want that is I'm more concerned about the time it takes me to start the OS, cold start, than I am in terms of overall throughput. Now, the things that you're showing are amazing for throughput when you're doing like large inference or like traditional sort of GPU. but those of us who know that's a limited time opportunity, right? There's lots of money, the space is frothy, so there's tons of money to just solve problems by throwing GPUs and expensive infrastructure at the problem. Now, that doesn't work well for agentic systems because you're actually taking the opposite end of the spectrum. You're creating these kind of micro-threaded agents that exist for a moment in time. They're ephemeral in nature. So all that stuff that you're outlining doesn't really work. So if I was looking to optimize for agents, and you might have already done this, I don't know. What you want to do is basically have a flag of some sort when you spin up your Docker instance that basically easily strips out all the stuff you don't want and starts under 100 milliseconds.
Interesting. Okay. Yeah, right. Fair. And so you're saying you're spinning up your agents containerized ephemerally. So
yes,
at a layer that you were focused. So, we're talking two different things. Of course, the host, not two different things, but there's a host OS, there's a guest OS within the container, right? Kind of what you've isolated, I'll call a guest OS. Now, a couple of key things here. It is interesting to consider that in your agentic systems, you kind of have these ephemeral agent workloads that you're spinning up and down. And there's a key call out there in that we are not yet at a place where we've sort of started to benchmark and optimize for the containerized nature of workloads, right? The theory here is container isolation does not mitigate the importance of the kernel, right? Whether you were virtualizing via VMs for more persistent workloads, or you were orchestrating ephemeral container-based workloads, at the end of the day, you are still hitting the CPU and the GPU through both Linux user space and Linux kernel. And so, however incremental the thesis is, that has an impact on time to start, time to first token, i.e. latency, jitter, so consistency and predictability, as well as overall throughput, right? At the end of the day, your kernel is controlling how you pull data off of storage, how you move data in memory. What is your swappiness? How do you govern your power states, right? So slimming down Ubuntu for a container and even slimming down Ubuntu for your host OS is powerful. It's important. It's a great start, as is being able to ensure your OS supports ephemeral containerized workloads. But ultimately, there is still that kind of under-addressed, unsung hero that is managing all of your critical I/O.
Okay. Yeah, so I would say you guys are, if I'm looking to spin up a data center and do a few dozen or a few hundred servers that do inference and model training, then you're optimized for that. Basically.
I think so. Our initial thesis started with optimizing where the biggest cost and pain we were starting to encounter was, and that was production inference at scale, right? But okay. my work and our benchmarks, especially around the setup time, are also finding that there's optimizations to be gained in training, in fine tuning, and also kind of a macro of what I will call experimentation. And one other thing before I hand it over is, and I think bare metal is where you get the most value, but we are, what I am also saying, and we're talking with AWS, Azure, the major CSPs and the major hardware vendors about, is even in turnkey stacks in the cloud, at the end of the day, the kernel is there as a key instrumental piece to your workloads.
Yeah,
but sorry, you were getting ready to say something.
My last comment, if you want to make this really valuable to the types of work that we're doing, focus on your optimization for micro-VMs, Firecracker most likely, and have this, because we don't need bare metal. What we need is an efficient, effective way to partition this as much as we possibly can, a single operating system or machine. And as far as I can tell, Firecracker is probably the best at doing that right now for the types of sort of ephemeral agents that we're launching. But the problem is most of the infrastructure and the OSs are not optimized for that type of sort of design pattern. So
Yeah.
if you want to truly position yourself as an, as an option for kind of agentic deployments, that's really all you need to optimize for.
So let me ask while we talk about it, and I'm asking you and the audience.
Actually,
So
sorry,
great.
Brian.
Go ahead.
Brian, I'm going to ask if we can defer the rest of this conversation. Jonathan, I know you have a question as well. If we can just defer that to about 12 minutes from now till we enter the show. We still have a couple really important messages that we want to hit before the top of the hour, if that's okay.
Awesome. Thank you, Robert.
And thank you, Brian, Dan. This was a great conversation. Really enjoyed it.
Really
Thank you.
stuff. So most critically, and Kunal, we'll get you right at the top of the hour as well. I really want to hear about the event that you were at in Vermont, but we need to spend a little bit of time with the Global AI Hackathon that's coming together out of France. Arsène and Jean-Marie are here with us from Paris. They've put together the Paris chapter have all the details on what the proposed global hackathon is and what the challenge is going to be, and the partners of that hackathon, which include TV5, the French global television station, which of course has 400 million subscribers around the world, and Tourism France, and these are the participants that are launching the hackathon effort. So Arsène, Jean-Marie, welcome. Thank you for all of the work and the preparation to get the word out to the community and elicit the formation of teams in short order to take on this wonderful challenge that has been tabled to the foundation. The floor is all yours, gentlemen.
Thank you, guys. It's a pleasure to be with all of you tonight. So yeah, so we are organizing the first global AI hackathon with the motto of learn, build, and earn. And we're looking to tackle a global problem. Every day, billions of hours are wasted looking for TV content. Every day. It's about 45 minutes on average per person. And we're looking to solve for that. And on the other hand, user watching intent content is not being discovered. So it's a big global problem to solve. That's what we're looking to achieve here. In terms of way to go about this hackathon, we've been discussing as a community. I know there are many among you who are in the startup community, and I'm not too much about acronyms, but there's one in the startup community, which is MVP, minimal viable product. Here I'd like to talk about MVP, minimal viable product and process. In other words, our recommendation is, and especially for those who've been building digital products like us for decades, it's very important early on to validate very quickly something that's going to gain traction. And here I think we got an opportunity to not only deliver the first open innovation output to solve these huge global products, but also to set the basis for a repeatable process that will scale over time, right? So we've been putting in a lot of thoughts into that over the week with Jean-Marie and Vincent, who's not with us today. And we've been talking about, as opposed to running traditional hackathon, as we've been seeing even around the globe where teams compete, we're going to try to change again, disrupt the game, and look for global collaboration where we all augment each other out, regardless of where we are, right? So one of the term, another acronym that came up in the discussion was the DAO, Distributed Autonomous Organization, right? So in the sake of focus and simplicity, we believe that actually, at least in the first iteration of what will hopefully become a global and repeatable operation for all of us, we don't need really something that's complicated, connected to the blockchain with crypto. We can keep it very, very simple. We're lucky to have first partner, as Rob mentioned, TV5 USA, who's investing some capital. And I'll happy to share now. I don't know how much time we have. I want to keep it simple too as well. I know I'm not the only one to talk before the top of the hour, but we could very simply design a first governance structure where in the short term, there's value being distributed to those who add value to the problem solving. We can do that very simply, even without crypto. There's very basic model where, for example, we could have validated push requests that capitalize on the amount that's being invested by the partner. And then the second part of it to think about that we started to put some thought in is, yeah, it's not a one-off. It's something where those who contributed value, who helped build the foundational brick, will get value in the future when that brick is potentially distributed by media, media actors, right? And for that same way, I mean, we can talk about attribution, and we could have like complex NFT processes, but no, maybe we can start very simply, with Google Sheet. I'm exaggerating. And over time, as we iterate those hackathon, come up with, we're going to build a tech and we're going to put it on blockchain and things like that. But my opinion is that let's try to get a first win. And Rob, I know we've been back and forth on the dates. We believe that potentially, December 5th to December 7th could be a good compromise between all the dates we talked about, right? And let's get a first win. Let's get this first MVP down, and let's win and build from there.
And thank you so much, Arsène. And to add some words on top of that, there is an ambition and a complexity here that we all see. That this dream of co-building a scalable framework that we could add layers on top of it on each hackathon, so with the time. So like kind of a multi-agent global framework with local chapters having maybe some subdivision and maybe co-creating a database or a bibliothèque of data, of metadata altogether, and then orchestrating that. I don't have a clear, detailed technical vision, but as we said, we need to make it as simple as possible so we deliver something that could be a proof of concept that we can all collaborate all together in a global project instead of competing.
Wonderful. So, to summarize, within approximately 3 weeks, the beginning of December, we would be running a global hackathon with teams from communities or chapters all around the world that can apply. Our partner 42, that have 53 campuses in 40 countries around the world, that university, the Open Forum University, they may be nominating some student teams to participate. TV5 has ponied up a deposit for a first cash deposit to support the hackathon, which is wonderful. And just to reiterate, clarify that if this results in obviously a usable product going forward, then there's market placement. That's a potential for participants, and thus the DAO concept. So it's an open call for teams. Ruv, I think exactly as you're saying that hackathon proof is in the pudding, show the process, as a structure for engineers to dive in. And
can we create the dream team? We got Chris on the call. We've got Nick. We've got Vlad. We've got all these guys. We should create like the dream team here and just like see where we can push this thing. Right?
Yeah, there's going to be as we get together. We had the kickoff meeting. The big challenge, which is reducing that 45-minute average search time for content down to as small as possible. We'll break that up into pieces, and then teams and then the dream can take on the hardest part.
Explore that. Let's explore it for a moment. So you're saying 45 minutes to find content. Is that like me clicking around trying to figure out what I want to watch tonight?
Human beings around the world. Right, Arsène?
Yeah, it's a problem that, and full disclosure, I've been working in the TV industry in the US like about 20 years ago. And at the time, I already knew the TV5 more than other channels, people trying to solve for that problem. So it's actually, it's a global issue that people wanting to look for content, because by nature, content is kind of gated and moded. You have to jump from one platform to the next and start over your queries and things. Just the fact of being able, as an agentic solution, to break down those modes and create a global system of data syndication, or whichever way we want to call it, consolidation, and then being able to query that to create user value would be a wow factor in the media industry for sure.
Well,
afterwards.
Like a TVOS. But go ahead.
Where does the IP lie after the hackathon?
It's yeah, well that's it. Within the DAO of the participants of the hackathon.
Can we do this with some crazy crypto scheme? Nothing against DAOs, but can we just put it out there as an MIT license?
I don't know anything about it, but about the DAO or crypto. I'll let you guys talk about that who are familiar with it. But the key concept is the participants in the hackathon sharing the collectively on the IPs. Is that right, Arsene?
We need to invent a model where there is a sharing revenue between the sponsor that brings the ID and the setup budget, us as the global organization team, and the contributors. So
why does it have to have revenue?
No, I think
if there is one day revenue, if for example we create with one or with TV5 or another sponsor on the time an API or an app or a GPT app, for example, and that brings revenue, that would we would have a sharing revenue between all the
like a royalty. Okay.
Because the sponsors want money.
That's the percentage to make it a scalable process.
It's because the sponsors are giving money, so they want something back.
The sponsor, like for TV5, even ask, "Can we have some shares?" So they are clear that we are the owners of the IPs. But of course, if we want a repeatable, scalable process as an open innovation new process, we need to share smartly the value.
So the plan is TV5 will incorporate this into their product.
Exactly. You're building infrastructure for them. So
not necessarily TV5. I mean, it's not about TV5. That's very important to understand.
It's beyond, yeah.
It's really an open source brick that can then be built on top of. So that's important to understand. It's not something that's specific to TV5. The problem to solve is global. It's not related to.
And it could be someday be directly on the TV OS. And like in a hotel bedroom, you could have like a guide and asking, okay, can I have a comedy tonight? What kind of comedy most popular you can bring? And this unsiloted answer would come. That's all it is. So no, the idea comes from this kind of TV5 as an open innovation, but it's transversal. The idea is to ask what is on Netflix, what is on Prime, what is on having a global guide.
To be platform agnostic in a way, right?
Okay.
And the people said that there could be an economic model where we could all win on that.
Progressively, I think it could also go beyond, even like we discussed this last time, beyond TV. It could go into like print. What's my digital persona? So
completely.
That yeah.
Even other contents. It doesn't have
what's on theater tonight? What's on a bar next to me tonight? What's live band is playing in my city tonight?
Right.
It's about discoverability, unsiloted. On the global.
Totally, great points.
So there's something I want to mention though in terms of intellectual property, and this is a really good sort of segue into that discussion. One of the reasons why I have a tendency to put my stuff as an MIT license is it's essentially permissive. You can kind of do whatever you want with it. It's essentially as close to public domain as you can get. Now, the question is, why does this crazy techno-socialist give away all this stuff? I live in a world that I have to use my stuff and I expect my clients to be able to use that stuff too. But I don't want to have to constantly rebuild all the stuff that I've already built just to make it work with the customers I'm working with. So one of the benefits of the MIT license for what's being described here is you can then repurpose it in a commercial fashion. So hypothetically, let's say I show up at the hackathon and I use AgentDB to create this super fast, smart reasoning system that learns from each viewer, probably what I'm going to build. In that scenario, we're successful, let's say, and they want to use it. Now there's a dilemma, right? I've got this thing that we use that's super crazy and super fast. But now, because I put it in the MIT license, that means that they can comfortably use that core component that I built. Within that, we can share revenue, we can do royalties, and oftentimes chip companies come and they want to take my Rust and put it on a chip or something. I'm in a position where I can monetize my free really easily. So that's something to consider when you're building your stuff. If you're choosing like GNU style, or I guess that would I call it right leaning. I'm not sure which direction it is, but things that basically make you contribute all the stuff back and give attribution. that becomes really hard. So when you're thinking about building stuff, and there's this sort of difference between I want visibility, I want people to know I exist, I want to build stuff and give it away because I'm a crazy techno socialist, whatever it is, then you're going to want to probably go more towards the MIT Apache spectrum. Just throwing it out there. License,
just real quick,
yeah.
Just real
Yeah, go ahead.
quick note to the Paris team. I hadn't heard how it's positioned, but if TV5 is putting up the $5,000 bounty, if they feel that that bounty is the payment for the actual work and not a prize alone, then that may need to be discussed as well in regards to what Ruth is saying about the MIT license.
Entirely. There's supporting the hackathon, and then there's some concept of prepaying for results.
Yeah,
right out.
Well, so, it depends if they consider that payment and that the ownership of the work gets transferred to them, or if it's just if that 5,000 is a donation to the DAO, then it's gone. There is no ownership.
It's a donation.
Yeah,
it's not about the money, guys. Like, you're doing this. At least you should be most likely thinking of it that this is a way to show what you can do in a public forum with visibility. You know, the money, let's be honest, 5K in a frothy AI world is not anything.
Exactly.
So it's not about the money. It's
sure,
about,
we get that. It's about the ownership of the work that exists at the end.
Right.
Yeah.
Exactly.
Where does that ownership sit?
A scalable model. So if it's not a good model, we're going to do
no, we don't. I don't have a solution, but it's as good as any that I could think of.
Everybody who participates and comes together around the hackathon, if there's IP that comes out that has market value, will participate in the revenue of that market value. Yeah. Right? And we can split down we can figure out the specifics over the next 3 weeks as we get going. And then what the categories of the teams are, of where their participation falls, or where teams want to focus on what aspects of the problem. But it's a wonderful opportunity. The second hackathon is lined up with Tourism France and their own, challenges with discoverability in the new era of GEO versus SEO, and all the myriad of beautiful small businesses across the countryside in France that are looking to, be discovered by travelers around the world. So there's lots of really neat stuff, and these projects can come regular fashion. So great opportunity for us to think through the exercise and come together and build a bunch of stuff, right? Learn, build, and earn. I think that was the motto. Yes.
It is.
Fantastic.
All right.
The weekend we put together a big jamboree on it for a week, so we can all get together on Zoom early next week.
One thing I wanted to just quickly mention here is that our colleagues, some of our community members who are from Google in the London chapter, they have offered to support, not sponsor, some of the infrastructure. I need to clarify whether that is for London or Europe or across. I didn't put that in. So they say it is frictionless access is what they say for those 2 days or so. So I guess I was wondering if the rest of the community member have connections, and this is up for discussion here. If we want to reach others as well, like AWS or even Anthropic and others, if anyone is, if they are willing to support, I guess in terms of infrastructure, that may be something we can explore. But Google have the guys here have offered to offer support as frictionless access.
Let's clarify what you mean, Mandeep. Do you mean they've offered to give the Agentic Foundation members Google Cloud account access?
For those 2 or 3 days, the participants of the hackathon, they will give access to the infrastructure.
We take it.
GCP?
Cloud Run. Cloud Run's all you need. To be honest, if you're using Google, everything else is secondary to Cloud Run. If you're doing agents anyway. We need Cloud Run access. It's awesome. It's fast. You get GPUs.
Awesome.
Yeah.
I think so it's a high level, but we need to get something properly agreed. So we will do that over the next few days and come back.
Other thing to note, if you're pitching the Google guys, a lot of the breakthroughs that we've had recently are directly related to DeepMind. So, for example, the reasoning bank concept is a Google DeepMind research paper that came out in September, and the Quick protocol, that UDP sort of quick handshake thing that I've been telling you guys about, that's also a Google sponsored protocol. They didn't know what to do with it, as far as I can tell. I think our use case around really fast sort of agent intercommunication is actually the optimal use case for that tech. So if you're looking to say, hey, we got some Google stuff in there, we do.
Mm-hmm. Really neat.
Yeah, really cool stuff. You know what, guy? Yeah, there was, just to jump around a little bit on the conversation, I see a raging OS conversation happening in the chat. Vlad, you want to summarize where we are in that? I love an OS conversation, so, but go, want to summarize
I don't know
where
if I
we at
can
here?
summarize, but I mean, I just put like my little tidbit in there. But actually, before I say that, Madvip, could you hit me? I think we're on LinkedIn because I'm actually tied with AWS Paris people. So I might just forward them the hackathon information and they might give us support.
Yeah.
Except the only thing, the AWS, the Paris office moves like at very glacier pace. Like, so you need to give them like enough sort of like head time to actually do anything like it.
Yeah. Oh, also, Vlad, mention the Boston stuff you're working on, the Boston meetup.
Oh, the Boston stuff. Yeah, I don't know anybody else from Boston here. Yeah, we are organizing. Yeah, Roof, thanks for your support. We are organizing the Boston chapter, and we're looking having an event at sometime like early January. I think that's our first. So the thing's moving along, and I don't know if you've been following updates because looks like we are getting the Microsoft space because in Boston it's the most accessible sort of building, and Microsoft is very generous supporting community events like that.
Yeah,
and that's the problem is because they booked up a month ahead for like many things.
Okay.
Yeah,
well,
and
we
about
do this for, let us know.
Yeah, and about OS stuff, I mean, the only thing is my primary choice, if I can, is actually BSD, like for very boring stuff like networking and storage. And I don't know anybody else has that. And it's easier, but usually BSD is closer to Mac, like it's almost like one-to-one for the user space. But
the one thing I will say, it's never been easier to roll your own OS. Like you can literally vibe your own OS at this point. All you need is a Docker instance and the willingness to muck around with it.
I built my own distributions for embedded stuff. It actually, typical distribution takes 48 hours to compile on like 3B beefy servers, so the amount of code there. But maybe like you do, like, I mean, that's the amount of code there is massive. Like we're talking like billions lines of codes. I mean, you can vibe it. I mean, one question is why?
Why not?
Actually, maybe it's a good thing. It's like if you want something very specialized, like so that might be like a good thing, like because there is 48 billion lines of code because it's like every single hardware like thing and like it's not every single like service, but there is a lot of stuff like that. If you're building a robot or something, you want something super specialized, and that you can actually vibe. And probably the way you would vibe it, you don't want to vibe from scratch. You would just want to somehow like build like a knowledge base of existing like OS code out there, and it will make the agents to like just plug the existing pieces, maybe optimize it and put it together. Like so.
Yeah, it's. I think I saw a comment from Dennis. It's all the other junk that you get with the OS that you don't want or need. And if you're gonna roll your own, basically, I think what you're doing is trying to strip everything you don't need. Really.
But that's the problem because you think some particular thing is a junk, and it might be like life like necessity for somebody else, like in the other way around.
Well, I think that's why you have package managers and things that are sort of afterthought. I don't know. I do this stuff just because I can. I don't know if there's any real reason to roll your own just to see if you can do it.
Oh yes, somebody mentioned Yocto. Yeah, why is it Yocto? I mean, that was my basically.
Yeah, I'm surprised no one's done like an AI on top of Yocto. So, here's my hardware, here's what I'm trying to do. Create me the optimal Yocto definition and build it and compile it. I think that'd be an interesting one. We use it a lot in the embedded space, like informatics and stuff like that.
Yeah, Yocto was my basically, that's what I was saying when I was building, but that's the thing, just to build the Yocto distribution just for like a simple device, it's like 48-hour like run basically.
Give us the simple explanation. What's Yocto?
Yocto is so if you want to build like an Android phone, right? It's a source code for everything that it's needed, from basically very, very low level, from the bootloader to the graphics to web browsers and everything. It's like a massive code, like it's basically pulls out collection. And you can specialize, you can say you develop this specific chip, like, so usually what people do, it's called board support package, like you created your own motherboard and then you build a little package, like define your hardware, what exactly you need, and then you build the whole thing. So you can actually choose, you can choose like Android, you can do something like a Kindle, like there is basically like a giant file with like yes or no answer, like things like,
basically,
and then you just
every package that you want embedded.
Yeah, every package, but different from the traditional OS packages like Ubuntu, is because embedded things they build once, like you build your robot and it just goes, like robots do not update their own packages, right? It becomes version something, like, so they
depends which robot you're talking.
I mean, it depends what robot, but usually most embedded like specialized hardware, they just build it. Like if you have your like a little webcam sitting there or something, right? It just build once and that's it. Like, and next time they will just rebuild the whole thing either from scratch. You can actually Yocto. It's a good thing about it. You can first time to build it takes 8 hours. If you change the little thing, it's actually very good understanding what changed, and it can do incremental builds. Yeah, but I would highly recommend Yocto if you're building your like own hardware. That's
basically any Linux distribution is probably built by a Yocto recipe. So
no, I would not say so. It's usually very big and embedded space. It's mostly devices. So probably your the machine that sells the tickets for the trains, or the like some kind of like a coffee shop, like that probably Yocto. So the things that runs on servers, they just use whatever the Rocky or like Ubuntu. So there's like desktop and servers, they exist in their own world. Like, so it's.
By the way, if you're looking to do crazy things quickly, like Yocto or whatever, Yocto might be a bad example because it takes forever. But if you add like your Google Cloud API to the Claude Code Web, it suddenly you can orchestrate between Claude Code Web and the Google Cloud really easily. So if you use, like, for example, if you want to set up like the Google or the Google Cloud Run, which is their sort of serverless environment, you can spin up GPUs instantaneously directly from Claude and let it fool around with it, and it creates all kinds of crazy stuff. One of the other things you can do, there's a service from Google called Google, I think it's Cloud Build or something like that, and it allows you to use build services. So you can like optimize different builds for different environments if you're looking to do like distributions, like package distributions for Rust or Go or something. It's kind of fun to play with. It's worth taking a look at. Make sure you enable your environmental variables in Claude Code Web, and make sure the full network access is turned on. Once you turn on that, it's actually a pretty astounding system. Lastly, the one thing I've been doing a lot of is using the E2B instances from Google Cloud Web, or whatever they call it, and that allows me. I did a test the other day. I did 5,000 E2B sandboxes, and that's Firecracker as well. And I had it running for, I don't know, about 5 minutes, and it instantaneous, worked like a charm, and it cost me, I think, less than 10 cents. So really cool system. And I think the guys at Manus if any of you guys using Manus, it's all built on E2B. So you're basically doing the same thing Manus is doing at that point at a fraction of the cost.
So Roof, you said 5,000?
Yeah, 5,000. That's my biggest test. That's the biggest test yet.
Because in my experience, when you go like over like 500, the traffic between individual boxes, basically, it
Quick
starts killing the system. Like,
so that's why Quick comes into play. So the Quick UDP solved that. So if you're using if you do MPX agentic flow, ask to create a federated cluster, because I got a federation now built in, and then create a federated cluster using Quick, QUIC, and it allows all the agents to sort of communicate with each other in a kind of without a handshake, because it's fast. It's
but there
secure,
should be like some hierarchical, because I mean there was a from like old my statistics textbook, right? If you have a problem with the like the crowd decides like are they gonna go to the movie tonight or have a dinner? If it's three people, like and then three people, they will basically do it very quickly, right? And then it's I think maybe 10 people would never achieve any consensus if everybody has their own opinion.
I don't need to.
So if you try to achieve
yeah.
consensus with 5,000 people, like are they go for simple things? Are they going for a movie tonight or for dinner? And everybody gives like their own like arguments, right?
Different.
That would never like converge. Like
that's a different problem. So you know, one, why am I doing 5,000 instances just to see if I can? But the real reason would be some form of pre-training. So what I ended up doing, and I could probably share this, is I was looking to pre-train my AgentDB vector structure based on all the potential possibilities for doing sort of medical research. And so I'm looking at DNA, right? So the 5,000 basically said I'm looking at different parts of a correlation between PubMed and the vector and unseen patterns and learning those things, and then I'm creating a federated group of agents that are kind of attacking different parts of that problem without me telling exactly how to solve that problem. So it isn't a hierarchy in that scenario. It's a mesh. So there's different deployment patterns. Hierarchy just wouldn't work particularly well in that pattern. But the mesh allows for that sort of level of autonomy, the fault recovery, which means that I've spawned 5,000 instances and I've overloaded a couple of them and they don't respond correctly. It handles the reconnection process gracefully.
Okay. One thing you might look at, there is very ancient system. I think it's called T-System. It's basically it's a huge like cesspool of like task requests. Like so they basically each agent, so it's like maybe 3-4 agents from the 90s basically. So each agent, when they need something to be done, or like some like it just throws it in a pool, and like some agents that are like sitting idle, they go look on that and pick them up. But the hardest thing is like coordination. If somebody picked like a task, so it's not all 5,000 will go and pick the same task, right? It just you want to like distribute one task to maybe like 10, right? And so that's something to look, because there was a lot of work done, basically theoretical, like how to coordinate this type of like orchestration.
As someone was asking about what Firecracker is, if you've ever used serverless, you know, for example, AWS Lambda and Fargate and E2B and a few others, this is what underpins it. This is what allows for sort of really tiny VMs to spin up really, really quickly. And if you're into virtualization, as a lot of you guys know, I've been into for like 30 years. This is, for my opinion, the state of the art for the things I'm building. It's pretty cool. So if you're looking to build your own agentic infrastructure, like you're going and you're going to connect a bunch of servers together, this is the way to do it.
Just so you know, though, Firecracker is not a hypervisor, right? KVM is the underlying hypervisor.
KVM, yeah, or whatever, yeah. It's the glue, but the glue's important.
Oh, okay. So it's not.
Yeah. So I think I can use KVM. It says here use KVM.
Anybody knows is Amazon like, because they build their own hardware right now to isolate between the VMs, but is it leaking out or they just holding it for themselves? And
their hardware?
Yeah, like
dude,
the
that's
Nitro.
It's all proprietary. They're not making that public at all.
They're not okay, yeah, because I mean that's
good friends of mine that are in that team, man, and they don't even speak to me about what they're building.
Yeah, because that's the core of their thing, like, and that's why they can launch like things fast and like the whole networking. But it's very interesting, like.
Well, they're trying to drive down cost, right? They want to deploy hundreds of millions of processors and systems in data centers at the lowest cost possible, and at their volume, they can't find a vendor to sell it to them at the price they want, so they're building it themselves. Google's doing the same thing.
No, I think they bought. I mean, people actually build the physical. They do their own designs, but I don't know how they physical, like what the structure there. Yeah, but it's very interesting to see what they're doing, because it's.
It's hard to get info out of them, man. If you want to know, it's hard.
We can infer. We don't need to see it to reverse engineer it. That's the beauty of LLM. Tell me how it's probably built, and create a benchmark, and better it. Okay, go.
Yeah. But then you need to find the chip fab to actually build it for you, right? So that's the
Well, that's a different league, right? That's we
and they
we
won't
play.
talk to you unless you order in like 10,000, I think, or something like it.
Yeah,
I don't know.
If we want to get there, I got to stop giving away my software. the path to riches is not defined by social altruism or whatever it is.
Actually, interesting. Is anybody doing the hardware designs with the agents? Like,
yes, I've got a project.
Yeah, there's a lot of people using them.
Yeah,
I mean, the problem is, Vlad, with those companies that are doing that, they have decades worth of legacy design systems, right? That are obviously pre-AI, and they're all entrenched in their process and their modeling, their simulations, and none of it's AI. So the only real true AI hardware companies that are spinning up silicon are very young, modern ones. All the traditional ones are like just all traditional software.
But I was just doing something simpler because I tried to use Perplexity actually to design simple circular, and it actually knows enough about physics, like electricity, all this stuff, to actually come up with good design. The only problem with it, it's atrocious at building diagrams because it says like it needs like 20.
You don't need that. You don't need it. So what I'm doing, and we're almost out of time here, but what I'm doing is I'm taking my Rust libraries and then I'm pointing it at essentially saying, build me a Verilog, right? And then I run through their simulator. And inversely, when the hardware guys show up, that they always do, they're like, how can we improve this? I'm just pointing Claude Flow at their Verilogs and saying, how can we improve it? And then run simulations until you beat the benchmark. That's the entire gig.
Yeah, Verilog is okay, but if you actually want to, so I think the gap somebody said like almost 6 months ago, they very look at the physical design because Verilog it's kind of like this is what we're building, right? And then there is a physical layout piece. That's
oh yeah.
Yeah, but the AI doesn't need the physical layout piece. It just
somebody
needs the code.
does, right? I mean, that's
well, no. Once you get the Verilog, you can just pass it on to the fab.
Eventually, you need to spin some silicon.
You have to physically lay out. Verilog just says like what, right? And then there is a how, like.
Yeah. Right. Oh, are you talking where you're talking about the actual print, like where you're gonna put it in the motherboard? Is that what you're getting?
No. I mean, on motherboard on the chip, right? So where each chip is gonna go, and some things actually go beyond just electronics design because if you have USB connector, you don't want to have it in the middle of the motherboard, right? It has to be at the edge.
All right.
So there is aesthetics coming like so.
We gotta wrap up. This was an interesting one this week. We had a dip into the world of OS and hardware. Nice discussion around intellectual property. I'm excited just to create a dream team for a hacker, a hackathon. So if you want to be part of the dream team, let's create a WhatsApp group, and we'll see what we can create here together. I'm obviously have a bias towards using my tools, but let's crank something out and see how our DAO, maybe that'll make us a few bucks.
Okay.
I'm sure we can better 45 minutes. That's for sure.
Speaking of dream teams, the last thing, I attended a couple events, so there was supposed to be like an expert on agentic programming, and I got super subscribed people claim to be like consultants, and the level of basically they asked like a year ago essentially.
Yeah, well, that's because they're not inventing stuff; they're reading. There's nothing wrong with that.
I've been telling you, Vlad, and all you guys, man. This team here is literally the sharpest minds in the agentic industry. In the agentic industry, this is where it's happening. This is the cutting edge.
But I also been looking. Anybody looked at Cloudflow kind of things? But from other people, there's open
guys.
hands.
I gotta apologize. I gotta run.
Okay.
I'm late for a call, and I really appreciate everyone tuning in, as you always do. I love these discussions. And there's no better way to end a week, in my opinion, than doing an AI Hackerspace. And as for everyone that's offered to volunteer to do meetups in Phoenix and Seattle and wherever else you happen to be, let's just do it. It doesn't need to be particularly organized. And I think just show the sort of stuff we're doing today. And it doesn't have to be quite so crazy. You can literally just show them lovable, and that'll blow people's minds, basically. All right. That's it. I gotta go. Thanks
Thanks for
everybody. All right.
Have a good weekend.
Okay.
Thank you guys.
Bye.
Have a nice weekend.